So what I'm going to talk about is automation and automation for iOS. So I'll give a little bit of context on where the project is coming from. I'll talk a bit about Selenium because a lot of the work I'm doing is coming from Selenium. I'll explain how you can use that to test native apps and how that's not enough, and you also need to test hybrid. And hybrid apps. How you can use that to also test mobile web, and I'll give a word on how you can use that to also test real device and where you should or shouldn't use them, and how you can apply all that on scale. So first, I'm part of Michael's team. We are based in Europe. It's a fairly small team. We're 15 people, and we're responsible for everything. All the products that reach the European site, we're responsible for them. There is a huge part of that that's just web, but we also have Windows desktop application, we also have mobile now, and we're responsible for everything. So when we think about tools and the way we work, it's web, but it's also everything else. We are not an automation team or a tools team. We do anything that we want as long as we don't leak any high priority bugs to production. If that means doing only manual tests and it works, we can do that. If it's only automation, we can do that as well. I'm also a Selenium committer, so I'm responsible for the great part of the project. And I'm doing that on my eBay time. And a little bit of history. So these 15 people, so we haven't grown that much over the last 8 years. I think when I started we were 8 and now we are 18. So we keep having more product and we need to give the same quality without hiring more people. So the way we've done that is we moved from a completely manual team to an automated team for the web. Then we started to look at desktop application, and there was nothing, so we built an open source tool for testing Windows desktop application the same way we use Selenium. And now the challenge that we have is that we didn't find anything good enough for us to do mobile automation, so we started to look at that. We're looking at both iOS and Android, and I'm going to talk about the iOS part, but that's the project I'm working on at the moment. So that's the current focus, and that's what so Selenium. Michael already asked, so I think most of you are familiar with Selenium. What Selenium is for me is a browser automation tool. So that's what people know Selenium for, but that's not, for me, what makes it really cool. What makes it really cool and successful is that it has a super clean API, and that API is becoming a W3C standard. That means as a tester, when I write my test with Selenium, in 6 months, when the new version of Firefox will release, or 6 with Firefox now, the test will still work. When there will be a new version of IE, the test will still work. So I can spend time and invest time writing my test. They will always work because the API is stable. And why can we apply Selenium testing to mobile? So the way the Selenium API works is it describes the user interaction. And that's working really well for the web. So you locate your element, you act on your element, but all that API can be applicable directly to mobile, especially because all the browsers are now present on the phones. The API is already there, and it has all the user interaction described. The API is really stable, and that makes it super easy to test, because I can take the test directly from the Selenium project and apply them to my project. So all the unit tests, and the project is TDD, I don't even have to write the test. I can test the test. I can take them from the other project. And I can reuse the test that I already have for the eBay app. Because the API is so stable, I can write my test, and when I rewrite and refactor the server, I can keep the test, because I know that the API is not going to change, and I won't have to, every 6 months, saying, oh, I changed the tool, so now we have to restart everything from scratch. So it makes it much easier to use. The goal for the project. So the main goal was to cut down the time that we spent for testing. It's not to create the magic bullet that will allow us to do everything. When we started, the goal was to be able to automate at least 50% of our test cases and just do that. So we don't do anything with fancy like gesture and all that stuff. We want to make sure that we can click, type, and locate elements at first. And if we have that working, we already have a huge chunk of our tests that we can automate. And that's important because we have quite a lot of applications. So we have 4 native apps, and those 4 native apps are present in, I think, 6 or 7 countries. So every time there is a release, we need to make sure that it works for all those countries. Some of the apps are also hybrid. So there's, for instance, when you use the eBay app, it switches back and forth, so pure native to hybrid and web. When you go to PayPal and you want to pay, you have to go to an hybrid app, so you need to handle that as well. And we have a lot of mobile web. The goal was also to reuse as much as we can, because we have only 15 people, and with those 15 people, we need to maintain all the tools and everything. So we can't just restart from scratch, because we also have to do the maintenance of the previous team. So we have our farm of machine to test the web. If we can reuse that for mobile, that's way better. We want to have it open source. It worked really well for us for Grid, because now the community is taking care of the project. So we invested a little bit at the beginning, but we have a lot in return. So when I said reuse the existing tools, so that's 2 parts. One is so reuse all the architecture, and the other one is when we write our test, because eBay is so big now, half of the time I spent writing my test is not really testing the functionalities, just preparing the data. If I can reuse those data preparation phases in my mobile test, I save a lot of time. The project itself. So the version is 0.6, so it's not completely released and mature. It doesn't have everything working, but it's enough that you can test most of your test cases. And if you have something missing and one of the functionality is not there, most likely you will have one command to implement. You don't have to start doing everything. So the project is open source. It's on GitHub. There is documentation, and we're trying to keep it up to date. And if you want more live support, you can go on IRC. So we are always on IRC on Reynaud, and there is a Google group if you want to send an email. That's the team. As Michael said, open source is getting some returns, and for me that means like eBay is spending 1 headcount, and I have 2 people working with me actively, helping me with the project. So you have more doing 1 patch here and then, but those 2 guys are really invested in the project, and they are really experienced. So on the left, that's Luke. He is working from the US. He is the current maintainer of iPhone driver for Selenium. And he is working, he really, for his company, he needs to have Safari working super well. So he's spending all his time making that Safari works perfectly. In the middle, that's Graham. He's working in Ireland. And he is, so what the part that he really needs is to have a really good integration with the continuous integration server. So he's providing all the code that allow you to put iOS into Jenkins and make that works perfectly. And that's myself on the right, and I'm working on Grid and Twin, so I have a good experience with Selenium. The technical choices. So if you want to join the project, you can change anything that you want except that. So that's the choices that we've made at the beginning of the project and that we don't want to change. So the first one is there should be no modification of the application on the test. That's one of the reasons why Selenium is so successful, is because you don't have to run the test code directly from your server. You don't have to modify the application. You can take the deliverable directly from your CI and test and validate exactly that. There is no language or test framework choice. So it's very bare bone. It's only there for finding elements and clicking on elements. If you want to test in Java, if you want to test in .NET, if you want to test in PHP, that's your call. The framework shouldn't force you to use any of those. It's just there to click on the button. It shouldn't force you to use BDD. If you want to use it in conjunction with BDD, you can. If you have another system, you can use it as well. And it needs to have and keep a very stable API, so we don't want to go away from the Selenium API. So that said, how we built the project. The first thing that we looked at was instruments. I don't know if you've seen instrument before. If you're working in mobile, that's the tool that comes with Xcode, and it allows you to test everything. It's provided by Apple. It's free, as in you don't have to pay extra fee as soon as you pay for Xcode. And it's working really well. So there is no real reason to not use it. When you write tests with instruments, that's what it looks like. It's in JavaScript. So if you're coming from the web, that's a really nice language. Not everything is perfect though. So if you look at the JavaScript, I don't know if you can, yeah, you should be able to read. Browsing the object tree is really annoying. So you can't just say, give me a button. You have to go to the front target and then the main window, then go to the table view. So you have to browse the entire object tree. So it does the hard stuff, but the API and all that are not great. It also has a fancy UI, and you can't plug that into a CI. So you have to use their UI. When you want to run the test, you have to click on the record button and press. But it comes with two really cool features that allow you to bypass those problems. So the first one is you can start instrument from the command line. If you start instrument from the command line, you can kill it, restart it, you can do everything from your CI. And the second one is, so instruments, the way it works is very different from Selenium. So you write all your tests, it sends all the tests to the server, and then comes back with the result. Where Selenium is send the command, gets the response, send the next command, send the response. But one of the methods in instruments is perform task, and that gives you a chance to do this cycle. So if you use that in conjunction with the command line interface, you can build something like that. So that's very much what Selenium looks like. You've got the client, you've got the Selenium API in between, and you have the server. If you do that, the advantage is that everything that's on the left in green, you don't have to do it. It's already done by the Selenium project. So you don't need to even worry about it. You only have to work on the right-hand side. You write the server that will control instruments. It does a little bit more than just doing the mapping. It also does all the setup and tear down. So when you want to install an app, you need to make sure that it's the right language, that it's the right keyboard install and all that. So it does a little bit of wrapping, but otherwise it's fairly simple. When you have that done, that's what you have. So that's the test in Java. The reason I write all the example in Java is because eBay is a Java shop, so I have them ready. But you can do the exact same thing in any language that Selenium supports. So this line is the normal desired capability from Selenium. In Selenium, you would usually say, I want to have Firefox version 17. Here you specify the name of your native app. You specify the version. That's a basic example, so you don't have everything, but you can also say, like, I want to have iPad with the Retina screen, or I want to have an iPhone with 3.5 inches screen, and I want to have the geolocalization whitelisted for this app. So you can configure everything you want. After that, you can start the remote WebDriver. It's either local or distributed, so you can integrate that into your continuous integration server if you want. And when you have that, you can use plain Selenium, so you will find your elements. The selectors are slightly different, because like CSS selector for a native app makes no sense, so you have a little bit of mapping involved, but otherwise the rest is exactly the same. And then you click on it. So you have something that is very similar to Selenium, and you can reuse all the knowledge that you have about your Selenium test, integrate that, put that into the same CI where you have your web test, and do everything like that. You have some challenges though. Not everything is exactly the same. The biggest difference that we've seen at first is the content. With the web, when something is, so when we test for eBay, we have to test in Europe in 12 different languages, so we can't rely on the text. We ask the developer to put some ID, and we can, when we want to click on the bid or bin button, we just say by ID bin, and that works. With native apps, you cannot do that. On the screen, so you have the International Mountain app. That's an example app from Apple. It's exactly the same functionality, but it's localized. So all the buttons have different text, and because you have to select by text in instruments, you would have to do 3 times the test or maintain your own dictionary. What you can do though is use that property. When you launch the app, inside the app you have all the localization accessible already. When you test the web, you don't have access to the server, but when you're on the real device or in the simulator, you can see, the server can see the app. So you can open the app, look inside, and inside you have the localization files already. So what you can do is, instead of giving the localization string, you can give the key that's served to generate that string. If you do that, your test can look like that. So that's at the top here, you've got the selector that is localized. So you see that it targets the name client, which means if I want to run the application in either French or Chinese, that won't work. But if I then switch to using the localized version and give the key, then I can reuse the exact same test for all the different languages. So you have one problem solved. I can focus on the functionality, and I don't have to maintain my own dictionary. So that's the first problem. That's how we solved it. The second problem is there is no Firebug for instruments, so you cannot inspect. You cannot inspect what you see. So what we built is this small tool. And so that's what happened when we want to debug one of our tests. So it's all in Java. You can put a breakpoint and start debugging the test. When that is done, so that stops. If you continue, that will open the simulator. And if something is wrong, so the simulator will pop up. And if you want to check where your test is failing and you get the exception, what you can do is open your browser and go to the inspector. So the inspector will, by default, target the simulator or the real device that is running locally, and it will show that as a web page. So you can mouse over, and on the right-hand side you see exactly what are the elements, so you can build the locator from that. So that allows you to write all the selector in a better way. And it's very similar. It has all the functions that you would have in Firebug or the Chrome console. So that's the two main problems that we had working on native. The next problem that we had is what happens when you have a web view. When you have a web view, that's what you see. So the page is not big enough, but just imagine for a single paragraph, you have 250 native elements. They are all a UI static text. Every time there is a line wrap, it creates a new one. So you need to work around that. To work around that, since iOS 6, you have a really cool feature. When you go onto your iPhone or on the simulator, you can go into Safari in the menu, advanced, and you can enable the web debugger. When you enable the web debugger, you can have something like Firebug or the Chrome console, and it directly interacts with the web view. What's even better is the web view, it's done for debugging, so you can execute some random JavaScript in it. Because you have that debug protocol, what you can do that is implement it on the server side and start executing some raw JavaScript against your web view, which means you can now have the native part and you can implement a plain Selenium driver in JavaScript for the web views. What it means is that your test can start looking like that. So the first part is the normal native part that I already explained, and when you reach a web view, you can do that. You can do driver.switch to web, and that becomes a complete normal Selenium driver. So you can start selecting by CSS selector, accessing the HTML attribute, and do things like that. You can handle alert and switch from one window to the other. When you have that, you can also test Safari. You don't have to do more work, it's just a consequence. Safari is an hybrid app. It's just that you're spending all your time in the web view. If you want to test Safari, that's what it looks like. And the advantage is that you have both the native and the hybrid driver working together. So in the first example, I'll show how you can switch between frames and windows and what it looks like. So you start the test, the simulator will pop up, and it will switch between the different windows. So that shows, so to open the window, you need the hybrid driver, but when you want to switch to another window, you have to click on the small page button at the bottom, and that's a native app. So that you can switch between the two completely transparently. So you switch between the different windows. The other part that is really nice when you're using this dual, so hybrid and native, is that if you want to fill in forms or click on elements, you can fall back to the native part all the time. So for instance, in this example, I go to an input field and I will enter some text. If you enter the text with JavaScript, you always have the problem where some of the events are bypassed and you don't fire everything that you need. But because we can fall back to native, it can use the real keyboard and type exactly the way it should. A word on real devices. So all the examples that I've shown are always using the simulator, and usually when I work with the simulator. But you can also test everything with real devices. Instrument is working for both simulator and real device, so it just works as is. The WebKit remote debug protocol work on real devices as well. So from a technical perspective, it's exactly the same. But it has some limitation. You cannot change the global setting. You can only change the global setting if you hijack your phone, and we've spent a lot of time not having to modify the application on the test, so if you have to jailbreak your phone, it's not really nice. From a scaling perspective, if you want to maintain 120 iPhone and you have to jailbreak them all, and it's really annoying. And you also need to handle app signing. So with the simulator, you don't have to do that. With real device, you have to do app signing. So that's real device. To summarize, it's possible, but I wouldn't recommend it, except if you want to do something that you can only test with real device. And so far, I've seen only one bug that was only on simulator and not on real device, because we're not testing things like performance. We don't make sure that we're still doing automation in combination with manual testing, and all the stuff where a real device will help, like the application feels right, it's not too laggy, that we test manually. We just test the functionality with the automation. A word on scaling. So I'm working on grid, so I want to have everything that works on grid. If you use iOS driver, that's what you will have. You have the client, you have the server, and the HTTP protocol in between. So what you can do is you can put a grid hub in between. And if you do that, that means that you can have multiple clients talking to the hub, and you can start running your tests in parallel. So you can fire your tests in parallel. If you do that, you can also run them in parallel. So you will have multiple servers with multiple real device and simulator attached to them, and you can run everything quite fast. That's the last demo. So if you plug everything I've talked about together, that's what you get. So that's Selenium Grid. That's what you get if you go to the Selenium page and download everything. On the left-hand side, you have 3 simulators plugged in. On the right-hand side, 1 real device, and I also put some web nodes just to make sure that everything was working. You don't see the code. That's not really a problem. What's important there, it's quite small. So you only have 200 lines of Java. And with 200 lines of Java, you can test on iPhone, iPad in 3 different languages. You can test on Chrome and Firefox, and you can test on real device. You also don't have to test. You don't have to do any installation on Eclipse. So that's the normal Eclipse. I only installed the Maven plugin because it's using Maven and TestNG to start the test. But other than that, you don't have anything at all. So it starts the test. You start them with TestNG. And that's what you have. So at the top, you've got 3 Mac running and using VNC to connect to them that will run the simulators. At the bottom, you have 2 VMs that are running the web and 1 real device attached to the laptop. and everything is running in parallel. They are all integrated with Eclipse, so if you're testing the web, you can just have one test for an iPhone, and then the following test can wait for the first one to finish, and validate that if you look at the item that you list with your iPhone, you can see the exact item on the web, and it looks okay. The demo goes for a long time because it's 200 tests. Let's skip through it. What I want to show at the end is the result. Again, no plugin install or nothing at all, it's just the standard test.ng result with some screenshots attached to it. And you can see that all the screenshots are directly there. You don't have to do anything, it just works out of the box. So, yeah, to summarize, what I want to there are two things that I want to communicate with that presentation. The first is mobile testing is nothing special. All the tools are there. We already have all the techniques to write the test. So we can use the tools that are given by Apple, combine them, make them work with Selenium, and you have everything that you need. And the second thing is I need more committers. So if you want to help, now is the time.